Okay. Okay, so my model has A equals 0.008, B equals negative 2.2, C equals 175. Okay? So my model is AT squared plus BT plus C, Y equals that. Okay? So plugging those numbers in, here's my model. Right, there's my A, there's my B, there's my C. You could write your model. And we all know how to graph a quadratic function. First thing we do is find the axis of symmetry. And the vertex. I wrote vertex. I should have written axis of symmetry. We know the axis of symmetry is at negative B over 2A. Well, that means that it should be at negative of B, which is negative of negative 2.2 over 2 times 0.008. Well, 2 times 0.008 is 0.016. And if I divide 0.016 into 16, I get 100. Okay? 22 is less than half, again, 16. So I get something less than 150. I'm getting an axis of symmetry around 140. Does this look like a parabola, or part of a parabola, with an axis of symmetry at 140?
Yeah.
Now your vertex has to lie on your axis of symmetry, and 140 is here. I haven't reached my low point yet, and I'm out here, right?
And then was wide awake.
So that means either I drew a bad parabolic curve, which is entirely possible. It could well be more exponential than it was quadratic, parabolic, or I made bad estimates. But the thing I do know is, since plugging this in here gave me this, and that's exact, so that plugging this and this in here told me that C was 175, well, that matches what C is known to be. C has to be 175. We used it here and throughout. So everything's consistent. So I know with very good certainty that I looked out and got a good solution. Okay? So it means, again, either this data really isn't well fit by parabola, okay? That these 3 points give you a parabola that doesn't match this curve very well. They give you a parabola that has a low point here and then starts going back up. Just keep going out like this. Okay? And I hate to say it, but your estimates also give you an axis of symmetry that's way too far to the left. Okay? I didn't tell you to make the graph parabolic. I told you to copy my graph, right? So if your results are as bad as mine, it's not because you didn't do the math right when you solved it. Both of you had to do a little rounding off, but you ended up with C values that were just off by less than 1, okay? You both had C values of 200. I think when you did it, you got 200.5 and you got 199 point something, okay? So we all did this right, okay? So you did a good job. That's how you solve the simultaneous equations. That's how you get a model and test to see whether it's a good quadratic model. Test failed. Now, if the test had worked better, and if we had more time, because we're kind of out of time here, and I've got advisees coming, so I'm going to have to quit here in a minute. And you probably have lives to live. So I would have asked you to estimate a couple more points on the graph, and then plug the t-coordinate of those points in to your model to see if it matches up with what you would estimate. Okay? So we'll do some of that, at least in my class. And we might come back to this in here, but that's kind of where we're going with it. And in the case of anybody who's in Will's class or in the distance class, it gives you a little context and some review of what you do to solve a system of simultaneous equations, okay? And that'll be the primary method you use in solving them in another course. And that's coming up, so we wanted to do that. And since we're going to be doing it right away in my class, you need to do it this weekend. Okay. This was a good day to get that in.